And our last official session, the next 55 minutes, would be about around credentials and communication of different work items by the Claims and Credentials Working Group and the DID Communication or DIDComm Working Group to present, and then we're gonna have open floor again. And sort of, I think the game is rather clear for everyone how it builds. Please keep your questions to the end, post them to Slido or to the chat, and we will collect them and ask them as
well. What's up?
Cool.
Okay.
You should mute yourself.
So I would invite Wayne, who is already on to start the presentation, if they have one.
Yep.
Yes. Thank you.
Cool. So you should be able to see my screen now. And cool. So the Claims and Credentials Working Group, I'm just going to go over what was in our charter again. First I'll talk about when we meet in case you want to join us. We would love to have you on our meetings. We're going to talk about what the charter was, what the goals are, and where the work areas are. And then we're going to dig into some specific items. Most notably, presentation exchange is the one that's been getting the most progress to date. And I believe Dan wanted to talk a bit about that. So I'll hand it over to him for that. Cover a few more items, and that's it. And we can talk about whatever. And then I believe, DIDComm is after that, or some working group is after that, and you might have to listen to that presentation too. But without further ado, this is the Claims and Credentials Working Group. We meet every other Tuesday at 3 p.m. Eastern Time, and the next meeting is next Tuesday. Note that we'll have a meeting the week right after that as well. We moved it because it conflicted with this exact time slot. So basically, if you want to get the meeting details, add the Decentralized Identity at Gmail calendar to your calendar list, and you should be able to find that. If you have any problems, reach out to Balazs or me. We're pretty active in the working group Claims and Credentials Slack channel. And lastly, if you want the charter, meeting notes, etc., you can go to this Notion page, and it will link you to everything. That's where we manage a lot of the meetings and the resources for our working group. These slides will be available after, so you can go in and click on it later. Cool. Goals. So our goals are to work on the request, creation, exchange, and verification of identity credentials or claims in a vendor-agnostic manner. We want to figure out, once you have verifiable information, how can you move it around, how can you mint new stuff, and how can you verify it, right? And this is all in support of the standards, of course, and interoperable use cases. We want to also advocate for the mainstream adoption of blockchain identity and credentials. Whenever people are like, how do we do that? We're happy to have that as a discussion in the working group sessions. Specifically, we focus on data formats, communication protocols, and taxonomies associated with claims and credentials. And this means that we're building stuff on top of the verifiable credentials, right? So you'll see shortly that presentation exchange is, okay, now that we have verifiable credentials, how do we request them and move them around? Communication protocols. Although we have working groups like DIDComm, we want to figure out specifically what is the relationship between these transport layers and also verifiable credentials, and of course the request issuance, presentation, revocation thereof. And then finally, taxonomies. As new things bubble up and we see more claims and credentials in industry, we want to keep track of them and start to categorize them. Going to go into each item now. So recent initiatives, we had presentation exchange, credential manifest, taxonomy, and there was a kind of a screwy project called freeclaims.org that I worked on. Upcoming initiatives, talking more about W3C interoperability at the credential and claims level, particularly. Web protocols, there have been like 2 interactions with OpenID Connect and how credentials can play into the claims role for that protocol. What other web protocols can we explore? Zero knowledge proofs was an active item too, and wallet portability formats. So presentation exchange.
Hey, Wayne, we lost you.
I was wondering if that was just me.
Sorry about that. I'm running like Gen 2 Linux and a browser Zoom, and it's all funky and doesn't like me. But anyway, I'll hand it over to Dan while I hold this screen up.
Okay, am I going to the presentation exchange stuff? Is that what I'm doing?
Yep.
Okay.
Yeah, you can co-opt the screen at any point, but a
Okay.
brief introduction. We're trying to solve this use case where the customer is like, I want a loan pre-approval. The bank's like, give us this stuff. That's a presentation request. Customer says, here you go. That's the presentation submission. And then the bank can issue credentials or whatnot. Over to you, Dan.
Okay. Yeah, so we talked a little bit about the Borg, and presentation exchange is very much like the Borg in certain ways. It wants to not care about any particular system it invades. It just wants to get in there and do its thing. So in this sense, like all the systems that we would want to invade are all the different ways that you could exchange credentials that everyone wants to run around like cats and create. So we've got OIDC, we've got DIDComms, we've got Chappy, we've got verifiable presentations. There's probably gonna be 14 more by the time that we're done with some of this DID stuff. So the goal with presentation exchange is to say, that's crazy. Why don't we have one way, instead of creating grammars for every single one of the essentially like outer transport, wrapper type protocols, why don't we at least have one way inside that we can describe a request for some proof, for some inputs from a verifier to a user or holder, and one way to send back the things that satisfy those inputs, and do it in such a way that you can embed that exact same data format in any one of those, and it would work. So that you can reuse code, not have to basically recreate the same exact thing over and over and over again across all of them. And this is just born out of mostly frustration. So if we go through it, there's basically two data formats that the spec specifies. One is presentation definition. This is this object, and you can embed it in any target format. We call them embed targets. Like it might be an OIDC object that you send over a request. It might be a DIDComms object. It might be a Chappy object. So you send out this object. It's composed of two main things: submission requirements. So the idea that you need to fulfill some of these requirements, like, hey, I need your banking. You got to satisfy all these criteria. I need some banking information. I need you to pick one of a group of A options, and maybe also need some employment information. And I need you to give me all from the options in group B. And I need some citizenship information. So I need you to give me one from group C, right? That's basically what this is doing. It's very, very basic Boolean sort of logic that can allow you to compose different paths that can satisfy things. Then down here, we have these input descriptors. And these are ways of basically saying, I need you to present me one of these things, right? Like based on what you said above about picking one from a group, for instance, I need you to pick one of these two sort of banking inputs. And what would happen is your wallet's going to get this regardless of that outer transport protocol, and say, okay, do I have any credentials that have this type of schema that they're encoded as? Or maybe do I have any that are this type of schema? If the answer is yes, then it goes down and says, well, now that I know I have that, do I have the right field type data? Like maybe, for instance, I need it to be from a certain issuer. So this first path selects based on the type of format. It's JSON path to make sure you can use anything, JWTs, VCs. It's also designed to kind of step over that mess as well. So this will find the issuer path regardless of what its target is, being one of those credential type formats, and then apply this standard JSON schema filter to say, hey, you know what? It needs to be one of these two DIDs that it's got to come from, right? One of these two banks. And maybe some other data that you also want to select on, like the routing number, it's got to be from one of these countries or something. So what this allows you to do is basically tell right up front, do I have the credentials to satisfy both the needs that I have and the actual data that's inside them to even do this, get into this dance. From there, once you've picked out the credentials or the proofs that you want to send back, there's a matching object, and I'm going to go right down to it. It's called the presentation submission object. So this is basically just presenting exactly what you saw up above and mapping it back. So this is like, if I was to pick out of their banking input 2 versus 1, because I had to pick one, I got all my employment data with this one, and then I had my credential input 1 versus 2, that I picked here. I'm basically able to embed this little object in any of those target formats. Right here, this is a verifiable presentation. It just as well could be the response object for a OIDC, object payload, whatever, DIDComm, doesn't matter. Basically, the spec is written such that this works exactly the same because it's using JSON path, and you basically encode it to select out parts of it, no matter where you're embedding it. So it sort of unifies the presentation of request of what this proof you need to provide me as the verifier, and then submission, and all the logic that goes into that, other than the outer endpoints that might be specific to OIDC or DIDComms or some of those other envelope related things. And we have some examples in here about how it might work with OIDC and similar. So here it is, the same thing that you saw above, right? Same object embedded. It just selects from a different place because obviously an OIDC request looks different than the other one. And then we also have some chappy stuff that Ori had helped write in here. So the idea here is like, let's just not, right? Like we've been just doing for a while with these things, and let's just not save ourselves some time. So
cool. I'm gonna share back the presentation. So yeah, to summarize,
that was a quick summary.
it will be the year of the desktop Linux. Okay, so if if you need to get something, then then you can use a presentation and request and presentation submission to do that. So next up is a credential manifest. You can look at some of this work. A lot of this work actually led into the presentation exchange, and I think we're gonna delineate what this should cover, reverse presentation exchange, and fix up that standard too, because it's useful, but it allows you to display automatically how do you request for information when that looks like an HTML web form or whatever. Taxonomy was our effort to keep track of all the ongoing credentials in real life. And reality check, there aren't too many in production today, but we've actually started to see some changes there, and that's super exciting. But we're trying to keep our nose close to the grindstone and just keep publishing as necessary. And when we have enough examples, categorize different ones. So new items. Zero knowledge proof, we don't quite know what DIF is best positioned to help with. There are a lot of suggestions out there. Everyone has some ideas, but there are also other groups in the space working on this. And figuring out the relationship with each of them is an important item to us, because we think that there are some activities that DIF can do really well in the domain of zero knowledge proofs, but we also want to figure out how to specialize in the right way. Another item are web protocols. Recently, within the past 3 or 4 weeks, we've seen 2 different approaches touch upon OpenID Connect. How can we mesh it with the claims aspect of OpenID Connect to send verifiable credentials, right? And as you saw, presentation exchange, we had some action there, but also Matter, Tobias from Matter, I believe next week will be presenting on OIDC client-bound assertions, which will also merge verifiable credentials and claims. Super exciting, because that means basically all OpenID Connect systems could prospectively speak our standards, right? Because we're building on top of it. So that could be huge for adoption, as mentioned in the goals. So what other protocols can we look at other than OIDC? What about IoT devices, et cetera? And what about intersection with the SIOP work that I know is going on really well and being led by Oliver and others, I believe. Another new item that was just introduced, wallet protocols. When we're copying and pasting a wallet somewhere, how do we move that? What's the format? Ori and Transmute proposed a universal wallet format for that called Universal Wallet, and I believe that spec is posted in the channel somewhere. And some people in different communities call these vaults, so we can still escape from terminology hell if we figure out what we can agree to call it. I think everyone just wants to talk about the same thing. And that's basically a summary of what we're working on as the Claims and Credentials group here. So thanks for listening, and happy to take any questions later on.
Hey, can I mention the taxonomy work specifically? This is something where I think, we really, really do want engagement. I think it's probably the lowest hanging fruit. I don't know who's on the call, if everyone's developer or not, but if you're not, the taxonomy work doesn't demand that. I mean, really what it's about is going industry by industry and identifying existing schemas that are out there that are commonly used. And the taxonomy is the place where we're kind of collecting them so that everyone knows, and we inform everyone across all industries, these are the ones you should probably skew towards, right? And so you really don't have to be a programmer. You just have to understand, like in the banking industry, for example, like maybe they use certain schemas. We don't know. I'm not in the banking industry. So that would be helpful, right? If you're in any of these verticals, you can hop in as a PM or anyone and be able to help.
Oh, and I believe we have Tobias here, who on a last item before time is up, wants to give a little bit of a preview on client-bound assertions and what the deal is there, because it's an upcoming item now.
Great, can you hear me?
Yep.
Okay, cool. I'll just give a quick overview. Hold on, I'll just share my screen. Can you see my screen with diagrams?
Yep, we can see it.
So in a typical OpenID Connect transaction, you've usually got a relying party going to some form of authority, often referred to as the OpenID Connect provider, that you make a call out to via redirects and requesting the authority to authenticate Alice, and then usually requesting some basic set of claims. And this usually comes out in what's called the ID token in OpenID Connect. You know, some of the things that it doesn't solve for, which is what we're obviously trying to do in this space in general, is when we have OpenID Connect transactions that involve multiple authorities at once for an identity transaction. You know, this is similar to the intent around the presentation exchange format as well, and this is complementary to that. But essentially we're solving for, partly in this space, solving for flows where we have information from multiple authorities that we want to pass back into our website in a single identity transaction. And that kind of gives rise to this need for, you know, a wallet to mediate in this flow. And one of the proposed ways in which this technology I've just shown now with the client-bound end user assertions is that flows like SIOP with DIDauth SIOP can be extended to pass back claims to a relying party, and the issuance can be conducted through this, what we've extended OpenID Connect to support. So a typical OpenID Connect transaction kind of looks like this. Usually you have a client which conducts an OpenID Connect request out to an OpenID provider requesting user authentication and some claims, and that OpenID provider usually authenticates the end user and then sends back a response, either directly via an implicit flow or indirectly via a token exchange and a back channel authentication or authorization code flow. And what this flow we have proposed is to extend the request syntax to be not only a request for end user claims, but for what we call client-bound end user claims. Because in OpenID Connect today, the ID token that is obtained from a traditional OpenID Connect transaction is not authenticatably bound to the client. The client cannot prove, the client being the wallet here, cannot reprove to another relying party if it wanted to, such as in this, that it had received the claims from the authority and that it can prove that it has the authority on behalf of Alice to present this information to the website. And so mechanically how this works is we use what's called the signed request object. So essentially all a request is expanded to do is includes a public key in the request, and the request is signed by the client, and it's requesting some claims in what's called a credential, where you specify the assertion format you're after, and the resulting response is a verifiable credential in either a JSON-LD VC format or a JWT VC format. And just quickly, the way in which we foresee the layering in of DIDs is, a DID is essentially an indirection over a set of key material. And so if you want to conduct an OpenID Connect transaction that involves binding the credential to a decentralized identifier, then in the original request you include the decentralized identifier that the public key is actually mentioned in, and then the resulting response will be, this is the token endpoint response that you get back from an OpenID Connect transaction, where there is now a new element other than the ID token known as credential that shows the resulting verifiable credential. And this model also solves for authenticating the end user in the process, and it's a complementary extension of OpenID Connect that we think could be quite a powerful flow.
Great, thank you so much. That's super important because, again, once we can federate into existing infrastructure, that's where you get your billions of users and thousands of companies using this stuff. So, and I'll hand it back to Balaj. We're done with the claims credentials part. Thanks for your attention.
Yeah, thank you everyone. And there's like healthy discussion going on in the chat as well. And I would like to also invite straight away Sam. Yay. And Sam, the stage is yours.
It does help if I mute though. Okay, so I'm talking about the DIDComm working group. This isn't credentials related, but we don't mind sitting next to our credential working folks. And there's some good collaboration there in the future. So the scope of this working group is to produce a spec that talks about authenticated message-based communication. So we think when you say messaging, sometimes our brain go right to human-based messaging, and certainly that's a possibility. But there's a lot more things that we can do. Anytime you have two parties that need to message each other about whatever, there's a handful of properties that they're going to desire, and so establishing a standard spec for this is really useful. And that way, the development of formats or protocols don't have to worry about the things that they get for free if they use DIDComm on top of that. So there's a little bit of a history of this. It originated, the work originated in Hyperledger Aries and IW29. That was 2 IWs ago. There was a whole bunch of interest, lots of work that I didn't summarize, and now we have a DIF working group. And then we're calling V2 what we're doing now, and there's a whole lot of improvements that have come about, not just the key type material stuff, but some other stuff that I'll talk about in a minute. It helps to have a UR here map, and so this is the UR here map for DIDComm. Underneath it is DIDs and DID documents, which is completely out of the scope of the working group. We want to build the communication standard on top of that. And then on top of this work, there will be lots of protocols involved. Credential exchange was mentioned, but any type of protocol you can imagine that you might want to have between two parties in a nice, secure way. And so, quite specifically, this is our area right here. It bleeds a little bit into here, in which case, if you're going to design a protocol, it helps. There's a couple of standard ways and mechanisms you can do that, like threading, etc., that are optional, but you can use those. But it doesn't get into defining protocols itself. That is work for other areas and other working groups. So there's some related work that's relatively important to understand this if you're going to dig into the technical details. One is an IETF draft on JWM that Tobias here, I'll blame him for that. That talks about feels like a JWT, JWE type of a thing, and that's because it is. It's designed to be a messaging format in the same family, and so there's an IETF draft for that. And then also related is the ECDH1PU method for encryption that actually gives us, in DIDComm v1, we were doing something slightly non-standard, and this is a better standards approach to do the same thing for authenticated encryption on top of the JW family of things. And so that's some important stuff if you want to dig in and understand the internals. So we've had some discussion on why some of these things, and the goal of DIDComm is to provide a bunch of attributes to sort of come for free without you having to figure it out as you're developing protocols. So security independent of transport is one of them. I'll talk about transports in a minute, but it's common to do HTTP and things like WebSockets, but being able to pass something over a Bluetooth connection is also very useful, and being able to trust the security in all of those transports is very useful. it serves as a foundational layer of interoperability, so that if you have two parties that speak DIDComm, then the amount of extra protocol on top of that is, you have the foundational benefit by by doing so. Another feature that we've worked hard to maintain is it's repudiable by default, and you can't support non-repudiation. There's a whole lot of use cases where repudiability is a very useful feature, and so we wanted to make sure that that wasn't enforced by the protocol, though you can do it. For those obvious cases where it's very, very helpful. It fills the gap between DID and protocols. I have a DID for you, and I want to engage in some way. What's the gap? And this helps that. And then, of course, it accelerates the protocol development because of the things you get for free. Transports, I brought up, and I wanted to talk about this briefly. So HTTP, HTTPS is an obvious use case for this. And that's a common one that we've seen in version 1 in the Aries ecosystem, used heavily, as well as WebSockets. WebSockets are very helpful when you have something like a phone that you want to connect to something else and be able to do more efficient transfer back and forth of messages. Another highly desirable one for offline use cases are both Bluetooth sockets, so you can connect over Bluetooth and pass stuff, as well as messages encoded in a QR code. We have a fairly limited expected application of that. I don't know of anyone that's trying to make phones communicate by blinking QR codes at each other, but it really helps in a bootstrapping use case when you need to pass some information, and we don't want to pass key material or things of that nature through humans because we're really bad at not typoing things. So QR codes are really helpful there. And there are other WebSockets that have been explored. In version 1, for example, we had one that was passed intentionally over IMAP and some other things like that. But the idea is that the message format itself, it has some applications to transport so that we can all use HTTP or WebSockets the same way. There's a little bit of variability there, but the core of DIDComm itself is not specific to a transport. So our current work covers a variety of topics, routing messages and how you get messages from one place to another place. That's particularly useful in the cases where you're trying to hide your traffic to obtain herd privacy, or you're communicating with an endpoint that doesn't have an inbound endpoint that we traditionally think of, like a mobile phone or an agent that sits behind a firewall. Also, a DID document service endpoint application, what needs to be in the DID document, and then how we actually apply that to DIDComm itself and making that happen. Transport application is simply the choosing the conventions with each transport that makes sense. When you're passing it over HTTP and the message is successfully received, what HTTP response code are you going to use, etc. And that way, it's just how to map DIDComm onto that particular transport in a consistent way. And then key type support in debating the merits of including various types of keys for both FIPS compliance and common types of keys used. This is the goal is to support as few as possible. That way we have less work to reach a broad level of interoperability, but while supporting the right ones to make sure that this has applicability in all the areas that we're looking for. And then join us, the DIDComm, DIDComm on the DIF Slack. We meet at noon on Mondays, US Pacific. And we keep a running agenda and update recordings there. They're also, of course, posted to the general channel, but I try to grab those links and stick it in the doc. So if you miss a meeting or you're curious what we've been talking about, listening to meetings is convenient because you can play it back often faster than real time. So you can buzz through an hour-long meeting in less than that, which is helpful if you're trying to stay caught up on stuff. So that is my summary. And there's only 2 of us, right? So now we go to questions.
Yes, indeed. The questions are open. So, use your hands or Zoom hand function, or there are quite some questions in Slido as well.
Yeah, why don't I start with some Slido questions? Yeah. There were some questions here for the presentation request work item. And someone asked, does the presentation request specification assume the credentials database supports JSON paths? Or how would you translate the JSON path to custom SQL schemata?
So presentation exchange, I would assume, is what we're talking about. it assumes that the credential itself is, you're able to run over the credential itself and the object to be able to isolate whether or not it is, has a matching field, or and run the JSON schema over the value to determine if the value is obviously compliant. If you're an implementer, you're going to have to obviously implement that differently if you don't have the objects, if you're not storing objects like that. But that's, JSON path is relatively well supported. I don't know if anyone has modules where they've translated that into like, JSON data that's been stored in some other form. But that's, that is the assumption that you can operate on the objects.
Okay. And a related question, someone asked about JSON path and also about xquery for performing requests.
Yeah, so xquery, I'm not super duper familiar. XPath was what JSON path was originally based on, which is like an XML centric traversal sort of query language. JSON path is, I would say, is probably by far the most robust and used, and had all the features when we did our analysis of like what we would need in the spec to be able to do the things we want. It was just the one that just was the most logical choice, it seemed.
Great. And someone, Isaac asked, how does Presentation Exchange interact with the SDS group? Specifically, there are complexities on how you query credentials stored in an EDV, metadata to store.
Great.
Yeah, so I think what the person is probably saying is like, well, if you have like an EDV where everything's encrypted and you can't see it at all, then how would you like see the objects and sort of run any sort of filters over them? And I think the answer there is that you would have some, either whether it's on the client and it'd be on the client because this might be totally encrypted credentials, you would have that same EDV instance on a trusted device like your phone, and you would have them unencrypted, so you'd be able to run over them in their unencrypted state after you pull them out of your local EDV encrypted layer. And that's probably how I would do that. Ori, maybe you.
Yep, that's a pretty good answer. I think it's technically possible for you to potentially modify that presentation exchange format to work over encrypted indexes, but I would not encourage that. I think most of the cases here would be, you're receiving a request that's about plain text credentials, and you're assuming that you're going to be processing that in a place that's safe to be looking at plain text credentials, whereas EDVs are for storing encrypted credentials, and you like reloading them into a place that might have them in plain text at some point in the future.
Gotcha. Yeah, that was kind of just the main question about do you pull down every single credential every time, or do we have like kind of skeleton, like if credentials get big, you can store just kind of metadata encrypted indices to query against? Yeah,
I think that's more a question of how do wallets and agents relate to encrypted data vaults, because those are the things that are responding to these presentation definition requests.
Cool.
I'm going to go ahead and split someone's question into a two-part question. First question is, how does someone asked, how does Presentation Exchange do quote unquote pick rules without ZKP? Or maybe another way of putting it would be, how does this compare to the more indie-centric or Aries version of presentation choreography? This might need to be a team effort to answer this question.
So I would say this, the idea of Presentation Exchange is that those values that you have down there described in JSON schema is pretty forgiving in terms of letting you define, how you're going to filter, and it has the full pattern capability, right? So one way I could imagine us, if I had to restate the question, obviously it works pretty easily with plain text credentials, right? Like you just see the data and you're like running over a thing, and that's easy. But when you get a statement that a credential needs to have X field, let's imagine it's going to be a ZKP. So it still has a schema, as a ZKP. It's probably still going to state a schema. And so you're going to say, okay, cool, I found like the ZKP credential that fits this schema. And then you're going to go down to your fields. And instead of your fields being lensing objects, what you're going to see is strings there as the property types. And those strings might be greater than 21 or something. A string that's set, that means this is the constraint or the circuit for greater than 21, and that has to be present in your credential. You can treat that the same way and say that it's got to be there, and the number has to be greater than X, or it has to be a Boolean of true. And you could still model it that way, is my thinking. Now, this is probably the least well-formed part of that spec, but I don't believe that it's impossible to make it work in that fashion.
Awesome. Do any other people want to chime in, or is that?
Hey, I have a follow-up question on that. So, I was more concerned. I asked that question, and I was more concerned about, like, for example, in JSON LD, when you sign the VC to build a VP, we sign the entire canonical document. So I was wondering, when you pick certain properties out of it, is the alternative to sign every property individually so that it can be verified?
That's a great question. So I think the best, I think the way I would want to answer that is, for zero knowledge proofs on JSON linked data, there's, to my knowledge, only the BBS Plus signature suite, which is developed by Matter and presented at IIW. And in that case, you're presenting a JSON linked data document that you can select properties from using the same JSON path and JSON schema semantics that you would for a regular JSON linked data proof credential. The difference is that it's a zero knowledge proof JSON linked data proof instead of a just regular JSON linked data proof. So there's no real, the presentation exchange definition specification uses JSON path and JSON schema. It doesn't rely on JSON linked data semantics in any format. It just operates on JSON. So if you can represent your credential as JSON, then you can use it.
Yeah, sorry about the confusion there. I was conflating ZKP with BBS. I meant BBS. But I'm still, like, I still don't understand, how would you verify that the property that you're getting back in the presentation submission is correct? Like, how do you verify the signature on that?
So there's still all the normal verifications that have to take place, right? No matter what your credential is, right? You find a JWS, you got to verify the signature, on it. You find linked data proof or some sort of exotic ZKP. They're all, depending on the format they're encoded in, they're all going to have a signature that you have to have a suite for to process, right? With JWS, it's like there's a JWS, there's these signature suites, there's these known ways to validate those types of signatures. So the whole concept here is that you use the selection logic to go find that this has a property that's accurate and fits the right description. If it's a plain text one, the implementation will be coded to pluck the value and test it immediately. If it's just the reference to greater than 21, it's obviously going to turn on that credential and use whatever signature verification is required for that target. So if it was like a ZKP snark or something, you might have to take it and put it in the algorithm's function that says, well, put in the assertion greater than 21, put in the signature payload, and then test the function and see if it comes back true like it was described in the JSON schema statement. And that's, so there's a little bit of process there depending on the credential validation types. It's not like it can't do all of that on its own, right? It does need some help at the end of the day.
And I think to simplify, scheme that does not support selective sharing or breaking up the credential, you can use that higher level concept. But the assumption is there will be verified signature schemes that support, like BBS, like selective sharing, or some Merkle tree signatures.
That's exactly what I meant. So to clarify, I guess, what are the alternatives to BBS right now which can do that?
It's either Indy-based or BBS Plus signatures. Those are the two.
Also the Merkle tree ones, which
Yeah, we use a Merkle tree one, which is like non-standard yet.
And then we're going to throw some snark crap in there in a few weeks. So there's also that stuff. But
Daniel, I'm done with your snarky crap.
I know, man. Isn't that crazy? It was named after me, by the way. I think we're getting out of the realm, though, right? Like the presentation exchange will be able to identify most of these upper level, like zero knowledge proof things. They emit like these strings, right? In terms of the presentation format to say, I may have been able to prove 10 things, but I'm going to prove these 5 things: greater than 21. I don't know, like years employed, all these things. And they're going to have strings that are essentially function strings that denote what that field does. And so your presentation exchange would basically select on those, find that they were present, and then you would make sure to run the functional output against the JSON schema encoded version of the circuit test. And you would have to have a library that understood that type of credential to do that. So it's not, the presentation exchange is not going to solve your library problem downstream about how to validate signatures on specific types of ZKPs. That is not its goal.
It's the ask and receive, not the validate piece of the puzzle.
All right, that makes sense. Thank you.
I just wanted to jump in there and add some additional commentary to mechanically how selective disclosure schemes work. You're not individually signing the different messages. So essentially what we do with the JSON-LD is JSON-LD has a process called RDF canonicalization that you can apply. That is the form in which traditional JSON-LD linked data proofs, that's the form of the data that gets signed. And essentially what that does is that takes a JSON-LD document and it normalizes it down into a flat set of what are called NQuads. So they're essentially just simple statements. They take a hierarchical data graph and they flatten them down into a single like string new line separated list of statements. And it's each of those statements that we discriminate against in a BBS signature. We're not signing them individually, but they are reflected as separate messages. So that's the denomination under which you can then derive a proof and selectively disclose from. But it's important to note we're not essentially signing them individually because there is a single output signature for which you can then derive a selective proof from. But there is, at that layer, we rely on a standardized way to separate out which statements we would like to sign individually and therefore be able to prove from.
Awesome, thank you. Yeah, I guess I really just need to work on learning about ZKPs.
Are there any more questions? Because we are out of Slido questions. And or are there any more questions or projects that could fit in the super broad topic of credentials and communication? Because if you someone in the participants working on some backyard project, then it's the right moment to bring out and talk about it, or another community member or other places, so that more people can learn about it and we can also discuss. There might be no such projects going on, and no more questions. Does anyone have any questions to any of the previous few topics? I'm asking this way because it's been a pretty long call and we could also bring the ending a bit closer, but we really don't want to keep the voice in everyone. So if you have something, then please bring it out or wait till the next meeting. Or I can also come back. Okay. I think